Welcome back to Aurora Tech Channel. Today, I will be reviewing the new Ender-3 V3 SE. I actually started 3D printing with an Ender-3, and it was probably the best $200 I've ever spent. My brother and I had a lot of fun and learned lots of things from that machine. At the time, most people looking for a budget printer went for the Ender-3, and since then, Creality has released several different versions, including the Ender-3 Pro, Ender-3 V2, Ender-3 Max, Ender-3 S1, S1 Pro, and the Neo series. At the same time, different manufacturers have been producing budget-friendly machines as well, making the entry-level 3D printer market highly competitive. Now, Creality has launched the Ender-3 V3 SE priced at $199. Surprisingly, it comes with some decent hardware that the Ender-3 S1 does not have. It appears to be Creality's response to other budget printers in the market. Let's take a closer look at what we can get from this $199 machine. The print volume is the same as the Ender-3 at 220 by 220 by 250. The maximum nozzle temperature is 260 degrees Celsius and the maximum bed temperature is 100 degrees Celsius. It has a different appearance from other Ender-3 machines. It comes with an injection molded base and a custom aluminum frame for the gantry. The motion system on the Y-axis uses linear rods, and there are no leveling springs underneath the bed, so the bed leveling relies solely on the CR touch sensor. They also added a strain gauge at the front left corner of the bed for auto Z offset. The Z-axis is using a dual lead screw synchronized by a timing belt, and the extruder is the same sprite extruder as the one on the Ender-3 S1 and Ender-5 S1. The heatsink is a new design. It's larger and is expected to provide better heat dispersion. The heated block looks the same as the one on the Ender-5 S1, which was larger and melted filament faster. The machine uses a full-size SD card instead of a micro SD card. The cable management is the same as the Ender-3 S1, which uses a single ribbon cable connecting the base to the print head. The part cooling is a higher RPM 4010 blower. Its size is the same as the one on the Ender-3 S1, but the airflow is stronger. The screen is a 3.2-inch color screen, and the UI is similar to the one on the Ender-3 S1 or the Ender-3 V2 with some extra options. The motherboard is a 32-bit board with a GD chip, and there's also a larger cooling fan that blows directly on the silent stepper drivers. The PSU is a Creality brand 350 watt. For other features, there are two adjustable screws on the X and Y axis to work as belt tensioners. The print surface is a single-sided PC spring steel sheet, and there is no filament sensor. I would like to thank Creality for sending me this machine to review, but before we get started, I would also like to thank Sunlu for sponsoring today's video. Sunlu has been involved in the 3D printing industry since 2013, so if you've been part of the 3D printing community for a while, you might be familiar with their filament. They have their own factory and a dedicated R&D team that stays up to date with the latest market trends. Personally, I really like their recycled filament series, which are priced at an affordable price of $9.99 per roll, as I appreciate the idea of reusing plastic to help the environment. Besides that, Sunlu also offers a wide range of options, including regular PLA, strength-enhanced PLA+, carbon fiber-filled PLA, and other more unique choices like twinkling, silk, rainbow, and wood-filled PLA. They offer PETG, ABS, ASA, and flexible TPU filaments as well. They also provide accessories like filament dryers and various types of 3D printing resins. For more information, please visit sunlu.com. The machine comes with laser foam packaging, and all parts are secured with foam and well protected. We have the base, the gantry, a 3.2-inch color screen, a filament holder, power cord, and some tools. When putting this machine together, one thing that's different from other printers is that this machine uses M3 screws instead of M5, but the gantry still feels rigid. Mount the screen at the right side and mount the spool holder on top. Connect some cables, and this machine is ready to use. Let's turn it on and try the leveling menu. There is no selection under this menu. It will start auto home, then heat up the nozzle. After a while, it will try to clean it at the side of the bed. Then, it will use the CR touch to check the height of the bed and the strain gauge underneath the front left of the bed to sense the height of the nozzle. So, the correct Z offset can be found by comparing the height measured by the CR touch and the strain gauge. After that, it will probe the bed 16 times to create a mesh. Then, I will load some filament using the new extrude option on the screen. It will home the machine and show a message for you to insert filament. Once the temperature is reached, press the knob to load it. Let's start our first print, a Benchy. I will use Creality Print, which has this machine's profile. The default PLA profile is printing at a 0.2mm layer height with a 0.25 first layer. The print speed is set to 180mm per second, but just infill will be printed at this high speed. The walls will be printed from 60 to 90mm per second, and the first layer is set to 30mm per second. For the acceleration, it is set from 1000 to 2500, and the first layer is set to 500. As this machine doesn't come with a network printing feature, I will just export the file to the SD card and start the print on the screen. The auto Z offset was set to -2.67, and I will keep this value and see if the CR touch and strain gauge combination set this value correctly. The first layer looks good to me, so it seems the Z offset value is accurate. The print speed is not as fast as those new Clipper machines, but it still prints faster than regular Marlin like the Ender-3 one, especially when printing infill at 150mm per second. The print finishes in 52 minutes. It's a little faster than the estimated 56 minutes. The quality is decent, the surface is clean, there's no ghosting or ringing, and the cooling is also good. Let's print one more with Creality Hyper Gray PLA, as I found this filament can show imperfections more clearly. Let's do a comparison. The layer lines are more obvious with this light gray color filament, but when looking at the real objects, their results are actually pretty close. As I found the product page shows this machine can print a 28-minute Benchy, which is 2 times faster than what I have printed, I asked Creality to send me the G-code and then reprinted it using the light gray PLA. The print finished in 27 minutes. It still looks alright when printing at the speed of 250 per second and up to 2.5K acceleration. However, the layer and surface looks better on the 52-minute one. It's more obvious from this angle. But this 27-minute Benchy still isn't too bad for an entry-level Marlin bed slinger. Next, I will print the Robo Alpaka and see what kind of print quality and speed I can get from the default profile. The print finished in 5 hours and 44 minutes. The time is faster than I expected, and the quality also looks okay. This is the print from 4 different angles. Let's compare it to other printers. When compared to the $650 Prusa MK3S Plus, the Ender-3 V3 SE prints faster and the surface is also cleaner. It's a bit faster than the AnkerMake M5C default profile, but the quality of the M5C is slightly better. When compared to the K1 is much faster, but the surface quality of the Ender-3 V3 SE is a little better. When compared to the Bambulab P1P, the P1P printing time is faster, and the surface quality is also better. Then, I will do some clearance tests, starting with the infinite cube. The print finishes in 1 hour and 42 minutes. The print quality is alright, the clearance is pretty good, and the cube can be played with smoothly. Let's try a harder one, the number slider. If the Z offset is ever set too low, the first layer of these tiles will stick together. The print finishes in less than 4 hours. The print quality is decent, and the slider can also move smoothly. Next, I will print the Honeycomb box for a retraction test. At first, I thought the hot end was clogged, but it was printing normally, so it's just that the retraction of the extruder sounds a bit louder than normal. When I take a closer look at the extruder, it's also working fine, so I will just let it print and see the result. The print finishes in less than 3 hours. All honeycomb patterns were printed successfully, and although there is a bit of stringing, overall the result is still okay. The quality is in line with other machines at higher price points. Then, I will try some ABS with a thin layer of glue applied. I will print a crate with ARI1 ABS Plus. there is some warping at the corners. Normally when the corners warp, the layers won't crack, so the patterns of the crate were still printed fairly well with some minor stringing. For an open frame bed slinger, the result is not bad. Up next, I will print a PETG phone stand. One of the tree supports didn't stick well, but I will just let it print and see if it'll ruin the print. As I set the maximum print speed for PETG to 125 mm per second, the print finished in 3 hours and 19 minutes. One of the tree supports failed, but it didn't seem to affect the print at all. After the support was removed, the print is functional and I have no complaints about the print. Then, I will print a TPU tire with the print speed set to 60 mm per second. The print finished in 1 hour and 9 minutes. The tire pattern is clear and the surface quality looks good. There is a little bit of stringing, but the tire is squishy and the result is pretty good. Finally, I will print a single layer PLA sheet to test the leveling and auto Z offset. The result is very good and is one of the best I have ever printed. Other than the corners sticking to the bed a little too well, this first layer is almost perfect. Let's talk about the pros and cons of this machine, starting with the pros. 1. The assembly is easier than previous generations of the Ender-3, as you don't have to put the gantry together on your own, and everything is pre-assembled. The time needed to put the whole machine together is less than 10 minutes, so it's in line with other latest 3D printers. 2. The spread extruder with the new heatsink and heater block works well. This combination allows the machine to print at 250 mm per second. When you look at the 27-minute Benchy, the cooling and filament extrusions are all good, so everything can keep up with the printing speed of 250 mm per second. It even works better than the Ender-3S1 in terms of print speed and filament flow rate. 3. The print quality is decent. This machine balanced speed and quality pretty well. When printing at 180 mm per second, you can expect the print quality to be very similar to a regular 3D printer printing at 50 to 60 mm per second. For both decorative prints and functional parts, the print quality is relatively high, with good clearance, clean retraction, and effective functionality. When printing at 250 milliliters per second, the surface is not as clean, but it should still work for functional parts. 4. The Auto Z offset works well. I just let the machine set the Z offset automatically when it started, and after that I did all test prints including a first layer PLA sheet without needing to readjust anything. The result of the first layer test is near perfect, and is one of the best I have ever printed. 5. The print bed is also using a new bracket that's lighter and thinner. With linear rods instead of palm wheels, the Y-axis can now move much faster. 6. In terms of network features, the printer works well with the existing Creality Wi-Fi box. I can simply connect the box to the printer, and it'll detect the Ender-3 V3 SE, allowing me to print directly from Creality Print. However, I still prefer to use this as a standalone printer that operates entirely offline, so that it stays unaffected by any network problems and consistently delivers reliable prints. Now for the cons. 1. The sound of the extruder is louder than all of my other machines using the Sprite extruder. When the filament was being retracted, I thought the nozzle has gotten clogged, but it was working normally. The sound of the fan is also a bit weird. When you set the fan speed to the maximum, it sounds normal, but when you set it to a slower speed, it sounds interrupted instead of just spinning slower. However, although the sound is weird, everything works normally. 2. This machine doesn't come with a filament sensor. It's easy to get a filament sensor anywhere for a few dollars, but it's not that easy to route the cable to the spool holder or on top of the print head. Even though this is a budget printer, I don't think a $2 filament sensor will make much of a difference. 3. On the product page, it mentioned an auto filament loading and unloading feature. Initially, I expected when the filament is inserted, the filament sensor detects it, moves the gear forward to grip the filament, automatically heats up the nozzle, and then purges a certain amount of filament. However, as the machine doesn't come with a filament sensor, it's just an additional option in the menu. After selecting the extrude option, it homes the machine and heats up the nozzle to 240 degrees Celsius. Then, it shows a message for you to insert the filament and requires you to press the knob again to start loading. While it combines the heating and loading under one menu option, it doesn't feel very automatic at all. 4. The heated bed cable still uses the traditional Ender-3 Pro strain relief bracket with zip ties. Clearly, Creality has a better solution used on the Ender-3S1. Featuring a high-quality heated bed cable is related to safety and reliability. It should be a minimum standard regardless of the machine's price. In conclusion, I am quite happy with this machine. For less than $200, you can get a printer with features like the Auto Z offset, CR Touch auto leveling, linear rods on the Y-axis, and a Sprite extruder with a new hot end and heater block that outperforms the Ender-3S1. The print speed falls somewhere between a standard Marlin firmware Ender-3S1 and a Clipper firmware-based Creality K1, and the print quality is decent. In my opinion, this Ender-3 V3 SE is the most competitive Ender-3 yet, and performs even better than the Ender-3S1. I do wish it came with a filament sensor, all-metal hot end, and a textured PEI sheet, but considering the price and what you can get, it's still pretty good. So, if you're looking for a sub $200 budget 3D printer, you could definitely take a look at the Ender-3 V3 SE. I put the link in the description. That's all I wanted to share about this machine. If you found this video helpful, please give it a like and consider subscribing to our channel. Thank you for watching, and I will see you next time.